Hello, mathematicians. Today we're going to take a look at lesson 6.5 in our math journals. And our focus and our objective today is to make sure that we are interpreting remainders when solving for division word problems and that we are able to explain our solutions. So first, we want to think about that word remainder. When I solve a division problem, sometimes my numbers come out very evenly and I might have an exact amount. Other times, I might have some things left over. So a remainder is going to be a number that might be left over after we solve a division problem. And we need to see today what to do with that remainder and what that might mean. And this is very, very applicable to real world situation. So what we're going to do to warm up is we're going to look at a word problem that you have in your journal to get our minds thinking about division and thinking about the strategies you've recently learned on how to divide. If you could turn to your math journal on page, let me make sure here, 201. You're going to see a page that looks very similar to what I have here. And let's read through the problem. Albert's Egg Emporium sells eggs in cartons of 1/2 dozen. Every morning, Albert collects eggs that his hens lay and packs them into the cartons. He packs as many full cartons as he can. If he has any left over, he eats those eggs for breakfast. There's that word left over. One morning, Albert collected 151 eggs. How many cartons did he need for the eggs? Show your work. Be sure to include units with your answer. Then there's a second part. How many eggs did Albert eat for breakfast? Show or explain how you know. Be sure to include units with your answer. Well, there's a lot here, so we need to kind of go back in our problem, as I always like to do. I like to read through once, and then I like to go back to make sure I know what the problem is asking me to do, and I want to make sure I highlight that important information. So I know that we have a 1/2 dozen cartons. Well, a 1/2 dozen, I know a dozen is 12, so half of that would be 6, and they give us a nice little image for us. And then he collected 151 eggs. I want to know how many cartons I would need for the eggs. Well, here's where I'm going to have to think about dividing my 151 by 6. So thinking about setting up my division problem here, you can feel free to pause the video and try solving this using your method that you've learned to divide. I will talk us through this and you can see if you got the same answer as I did. So if I'm thinking here, using my partial quotients method, what I might want to think about is what I can pull out here. So I want to think about how many 6s can fit into 151 without going over. I know I could do 10 because 6 times 10 gets me 60, but I wonder if I could go even more. What if I do 20? I know if I do 6 times 20, I will get 120. So what I'm going to do is I'm going to use that. I'm going to go with 20 because it gets me a little bit closer to where I need to be. I know 6 times 2 is 12, and I have my 0, and then what I need to do is subtract. What I'm going to have left over is 31. Now I need to think about how many 6s go into 31 without going over. All right, well, I know that I can fit in another 5 6s. So I would have to think 6 times 5 gets me 30. And when I subtract, I have a number left over, my remainder. So what I need to think about here is when I add 20 plus 5, I get 25. So I know he's going to need 25 cartons for the eggs. And I didn't end up with 0 here. I ended up with 1. And since it's less than 6, I know that I can no longer fit any more 6's into that number, so I'm done dividing. So my answer is I can fit in 25. I'm going to need 25 cartons, and I have 1 left over. Well, that kind of takes me to my next question here for number 2. How many eggs did Albert eat for breakfast? Show or explain how you know. And be sure to include units with your answer. So because we figured out that we had 1 left over, our answer here, scroll down a little bit, would be 1 egg. So he had 1 egg for breakfast. And if I were going to explain my work here, I might say something like, Albert ate 1 egg that was left over after he distributed 150 eggs into 25 cartons with 6 eggs each. Whoops. Notice that I was able to explain that using the information that I had from this first problem. You're going to be doing something very similar. Since this is in your math journal, make sure that you take some time and make sure that you solved this problem, whether you did it first and then played the video to check your answer, or you did it along with me. You're going to see an activity called fruit baskets for you to practice a little bit more on interpreting the remainders. I would like to go through this problem with you and think about what it is that these questions are asking you to do. So we're now going to be applying these skills and thinking about how we can use division and our remainders to make sure that we are interpreting them correctly. And if we need to round up our answers or what we need to do with the remainders, this is very important. So the 4th grade chess team is planning a fundraiser. They are going to sell fruit baskets. Oscar is in charge of oranges for the baskets. 3 students brought oranges. Olivia brought 29, Ozzy brought 31, and Olga brought 27 oranges. All right, so that is a good start. Since I just read that, let's talk about our oranges and let's underline our numbers here. That might be important. Each basket must have at least 5 oranges. Some baskets may have 6 oranges if there are any extras after each basket has 5 oranges. Let's look at that again. Each basket has to have at least 5 oranges, but some may have 6 if there's any left over. How many baskets will be needed for the oranges? Show or explain your thinking. To get you started, well, we need to kind of figure out how many oranges we're going to have total. So I need to make sure that I look here. My first step would be, let's add up our oranges. Our 29 plus our 31 plus our 27. When we add this all up, and please make sure that you are attempting to add this up as well, right along with me. And then you can pause the video and then you can check your answer here. When we add this all up, we are going to get 87 oranges. However, now we need to think about, well, since each basket has 5 oranges, what might we need to do with this 87 and our 5? This might be a great time to divide. Okay. So once we kind of go through, you could either use your traditional method or your partial quotient method, whichever one works best for you, we are going to want to see how many oranges we have and how many we'll have left over. Because part B asks us to think about how many baskets we'll have 6 oranges and how many will have 5 oranges. So you need to make sure that you are showing how you got this answer here. There is a second page that ties directly in with what you just did. So if you look on the second page here, the baskets will be put into boxes for delivery. Each box can hold at most 7 baskets. What is the least number of boxes needed for the fundraiser? Show or explain your thinking. What you want to figure out after you've already figured out your answers to the previous problem, you want to think about something like this. You will have baskets and you're putting them into a box. And think about each box can hold 7 baskets. So these little boxes I'm drawing inside the big one are going to be my baskets, and I know that this box can hold 7. I want to know the least number, or the smallest number of boxes that I could use for the fundraiser. And then lastly, number 3 asks you to explain how you use the remainders in 2 different ways to help you solve your answer for problems 1 and 2. So here you should have 2 explanations. If it helps you, maybe even number them so you know right away that you need to tell us 2 ways that you used the remainders to help you answer the problems for number 1 and 2. All right, mathematicians, take some time. This is hard work here, hard problem solving. I know that you will all persevere and do your best work. Make sure you are really reading closely as to what the problem is asking you. All right, off you go, and we look forward to seeing all your great mathematical thinking.